Welcome to the Times Horizon. Hope you guys are fine and doing great. You may have read about the recent news articles regarding ongoing debate on exomoons. It's a topic that's been generating a lot of buzz lately. In this video, we're going to dive deeper into this topic. You may have heard of exoplanets, which are planets that orbit stars other than our Sun. There are thousands of them that we know of, and some of them are even similar to Earth in size and temperature. But what about exomoons, which are natural satellites that orbit these exoplanets? Do they exist? And if so, how can we find them? Well, it turns out that finding exomoons is much harder than finding exoplanets. That's because moons are usually much smaller and fainter than their host planets, and they also have more complex orbits that can be affected by other factors, such as the gravity of the star or other planets. To detect an exomoon, we need to look for very subtle changes in the brightness or timing of the starlight as the planet and its moon pass in front of it. This is called the transit method, and it's the same technique that we use to find most exoplanets. But even with this method, finding exomoons is very challenging. In fact, so far there have been only 2 cases where scientists strongly claim to have found evidence of exomoons: Kepler-1625b and Kepler-1708b. These are both gas giant planets that orbit stars. They were discovered by NASA's Kepler Space Telescope, which observed thousands of stars from 2009 to 2013. The first case, Kepler-1625b, was announced in 2018 by a team of researchers from Columbia University in New York. They claim to have found a giant moon orbiting this planet, which would be about the size of Neptune and would dwarf all the moons in our solar system. They based their claim on data from both Kepler and the Hubble Space Telescope, which showed a slight dip in the starlight after the planet had passed by, indicating a possible moon trailing behind it. They also noticed that the planet's transit started earlier than expected, suggesting that the moon's gravity was pulling it slightly ahead of its orbit. The second case, Kepler-1708b, was announced in 2020 by a team of researchers from Yale University and Leiden University in the Netherlands. They claimed to have found a smaller moon orbiting this planet, which would be about half the size of Earth and would be one of the smallest exomoons ever detected. They based their claim on data from only Kepler, which showed a slight variation in the duration of the planet's transit, indicating a possible moon tugging on it. However, both of these claims have been met with skepticism and criticism by other scientists. A new study published in December 2023 by researchers from the Max Planck Institute for Solar System Research and the Sonneberg Observatory in Germany has cast serious doubt on the existence of these exomoons. The researchers used their own computer algorithm called Pandora, which is designed to search for exomoons more efficiently and accurately. They applied this algorithm to the same data sets that were used by the previous teams, and they found that there were simpler and more plausible explanations for the observed signals without invoking any moons. For example, for Kepler-1625b, they found that the dip in the starlight after the planet's transit could be caused by stellar variability, which means that the brightness of the star changes over time due to natural processes like sunspots or flares. They also found that the early start of the planet's transit could be caused by orbital eccentricity, which means that the shape of the planet's orbit is not perfectly circular but slightly elongated. These factors could account for the observed signals without requiring any moon at all. For Kepler-1708b, they found that the variation in the duration of the planet's transit could be caused by noise, which means that there were random fluctuations or errors in the data that were not related to any physical phenomenon. They also found that there was no consistent pattern or trend in the data that would indicate a moon's presence. In fact, they found that there was no significant difference between their model without a moon and the previous model with a moon. So what does this mean for exomoon hunters? Does this mean that there are no exomoons out there? Not necessarily. The researchers point out that their study does not rule out the possibility of exomoons in general, but only casts doubt on these 2 specific cases. They also point out that their algorithm Pandora is not perfect either, and that there may be other factors or scenarios that they have not considered or tested. They suggest that more data and more observations are needed to confirm or refute the existence of exomoons around Kepler-1625b and Kepler-1708b, as well as other exoplanets. They also suggest that future missions and instruments, such as the James Webb Space Telescope or the Extremely Large Telescope, may be able to detect exomoons more reliably and accurately. So, the search for exomoons continues, and we may still find some surprises in the cosmos. Exomoons are fascinating objects that could tell us a lot about the formation and evolution of planets and their systems, as well as the potential for life beyond Earth. Who knows, maybe one day we will find an exomoon that is habitable or even inhabited. That's all for this video. I hope you enjoyed it and learned something new. If you did, please like, share, and subscribe to our channel for more videos like this. And don't forget to leave a comment below with your thoughts and questions. Thank you for watching, and see you next time.